Chapter 1, Problem 11, Part A, tasks us with following a curved arrow to draw a second resonance structure of an indicated molecule. In this Lewis structure, single bonds represented by lines between atoms have 2 electrons each within them, while these pairs of dots represent lone pairs of electrons which reside on a specific atom. In this curved arrow, we're starting from a double bond and landing onto an oxygen atom. What this indicates is the movement of electrons from a bond onto an atom. So in our second resonance structure, we lose one of these double bonds, form a single bond, and those electrons move formally onto the oxygen to form a lone pair of electrons. This isn't a complete answer, though, because although we've indicated correctly where the electrons lie in this resonance structure, we have not indicated charge. So on the original molecule, this carbon atom has 4 electrons nearby it, 1, 2, 3, and 4. Because this carbon wants to have 4 electrons around it, that is known because carbon lies in the 4th column of the periodic table, has a formal charge of 0. Formal charges of 0 do not have to be indicated in the molecule. The oxygen of our original resonance structure has 6 electrons nearby it, 2 lone pairs and 2 bonds. Because oxygen is in the 6th column of the periodic table, it also has a formal charge of 0. In our new resonance structure, however, our carbon lost one of its bonds and now only has 1, 2, 3 electrons nearby it from these 3 single bonds. Because carbon wants to have 4 electrons, but it only has 3, that is a deficiency of 1 electron, hence a formal charge of positive 1. This oxygen has 7 electrons nearby it, 3 lone pairs of electrons, and 1 from this carbon-oxygen single bond, while oxygen normally only wants to have 6 electrons nearby it. This means that our oxygen has a negative formal charge. This is the complete answer to problem 11, part A. Part B asks us a similar question with a different molecule. This molecule begins with a carbanion, meaning this carbon actually has 5 electrons nearby it, which is indicated by this negative formal charge. And following the indicated arrow pushing, we have this carbanion move onto a bond, which is going to indicate a single bond turning into a double bond, and then our arrows moving from a double bond onto a carbon center. So our second resonance structure now has a double bond coming from carbon 2 to carbon 3. And the 4th atom, this 4th carbon, now has a lone pair residing on it. Similar to how this carbanion was negatively charged, this terminal carbon now has 1, 2, 3, 4, 5 electrons nearby it, which will be indicated by a negative charge. This is the answer to part B of question 11 from chapter 1.